Welcome back. In the first part of our conversation, we learned how your curiosity about building a simple website eventually led you into full stack engineering. Now, I'd like to ask something that almost every beginner wonders. What is the reality of working as a full stack engineer that textbooks don't prepare you for?
That's a question I wish someone had answered for me when I started. Many people imagine software engineering as sitting alone writing code all day. The reality is very different. Writing code is important, but it's only one part of building software. A typical project involves understanding customer requirements, discussing ideas with designers, planning features with product managers, collaborating with other developers, testing applications, reviewing code, fixing bugs, deploying updates, and continuously improving the product. Software development is as much about communication and collaboration as it is about programming.
That's interesting because many people think the hardest part is simply learning a programming language.
Programming languages are important, but they're tools. Think about a carpenter. Owning a hammer doesn't automatically make someone a skilled carpenter. What matters is knowing how to build something useful. Software engineering works the same way. Whether you're using JavaScript, Python, Java, C Sharp, or another language, your real job is solving problems. Technology changes, problem solving stays valuable.
Many beginners hear terms like HTML, CSS, and JavaScript almost immediately. Why do developers always start there?
Because those technologies form the foundation of almost every modern web application. Imagine constructing a house. HTML is like the structure of the building. It defines where rooms, doors, and windows exist. CSS is the interior and exterior design. It controls colors, layouts, fonts, spacing, and visual appearance. JavaScript brings everything to life. Buttons respond when you click them. Menus open. Forms validate information. Content updates without refreshing the page. Those three technologies work together to create the interactive experiences people expect today. Without understanding these fundamentals, learning advanced front end frameworks becomes much more difficult.
Speaking of frameworks, people often hear names like React, Angular, and Vue. Should beginners think of these as completely different technologies?
Not really. Think of them as different toolkits for solving similar problems. Imagine three different brands of power tools, each helps you build furniture. Each has slightly different features. But before using any of them, you still need to understand how furniture is constructed. React, Angular, and Vue help developers build modern user interfaces more efficiently. But underneath them, HTML, CSS, and JavaScript remain essential. That's why strong fundamentals always come first.
Once someone builds the user interface, what happens next?
The front end is only what users can see. Behind every modern application is the back end. Imagine ordering food through a mobile app. When you press the place order button, much more happens than simply displaying a confirmation message. The application checks whether the restaurant is open. It verifies your payment, stores the order in a database, notifies the restaurant, calculates delivery estimates, updates inventory, sends notifications. All of that happens behind the scenes. That's the job of back-end systems. They're responsible for business logic, processing requests, security, and managing information.
So, where is all that information stored?
Inside databases, think of a database as the application's memory, user accounts, orders, products, messages, appointments, payments. Everything needs to be stored somewhere safely. Different applications use different types of databases depending on their needs, but every full stack engineer eventually learns how to design, query, and manage data effectively. Without databases, most modern applications simply couldn't function.
That naturally brings us to APIs. People hear the term everywhere, but what are APIs actually doing?
Imagine ordering coffee at a cafe. You tell the cashier what you would like. The cashier communicates your request to the kitchen. The kitchen prepares your order. The cashier brings it back to you. The cashier acts as the bridge between you and the kitchen. APIs work in a very similar way. The front end sends requests, the back end processes them. The APIs provides a structured way for both sides to communicate. Today, APIs connect websites with payment gateways, maps, authentication providers, weather services, AI platforms, social media, and countless other systems. They're one of the reasons modern software can integrate so many different services so seamlessly.
Security is another topic people hear about early. Why are authentication and authorization so important?
Because not everyone should have access to everything. Imagine walking into a hospital. Patients, doctors, nurses, administrators, and visitors all have different permissions. The same idea applies to software. Authentication answers the question, who are you? Authorization answers, what are you allowed to do? Those concepts protect user information and ensure applications remain secure. As applications grow larger, designing good security becomes just as important as writing good code.
Let's talk about something every developer eventually encounters: Git and GitHub. Why do professionals rely on them so heavily?
Imagine writing a book with 10 other authors. If everyone edited the same document without coordination, it would quickly become chaotic. Version control solves that problem. Git keeps track of every change made to the code. Developers can experiment safely, review each other's work, undo mistakes, merge contributions, collaborate across different countries and time zones. Platforms like GitHub make teamwork much easier and have become an essential part of professional software development.
We've talked about building software, but how does it actually reach users?
That's where cloud deployment comes into the picture. Building software on your computer is only the beginning. Eventually, your application needs to be available for people around the world. Cloud platforms provide the infrastructure that allows applications to scale, remain available, and serve thousands or even millions of users. Deployment isn't just pressing a button. It involves configuring servers, managing environments, monitoring performance, securing applications, and continuously delivering updates. That's why modern full-stack engineers often understand at least the basics of cloud technologies and DevOps practices.
Many beginners think software is built by one person from beginning to end. Is that realistic?
Almost never. Successful software is built by teams. Designers create user experiences. Front-end developers build interfaces. Back-end developers implement business logic. Database engineers manage information. Quality assurance teams test features. DevOps engineers handle deployments. Product managers coordinate priorities. Customers provide feedback. The software development lifecycle, often called the SDLC, helps organize this entire process from planning to deployment and ongoing improvement. Understanding how software is built collaboratively is just as important as understanding how to write code.
Before we finish this segment, if you had to share one truth every future full-stack engineer should remember, what would it be?
Don't think of full-stack engineering as learning 10 separate technologies. Think of it as learning how complete digital products are created. Every topic you'll study has a purpose. HTML gives structure. CSS creates presentation. JavaScript adds interaction. Front-end frameworks improve user experiences. Back-end systems process information. Databases remember data. APIs connect services. Authentication protects users. Git supports collaboration. Cloud deployment makes applications available worldwide. When you see how everything fits together, learning becomes much more meaningful.
That's a fantastic way to conclude this chapter. Today, we've learned that full stack engineering isn't about memorizing technologies. It's about understanding how they work together to build secure, scalable, and reliable software that solves real world problems. In the next segment, we'll move from concepts to unforgettable real world experiences. We'll hear stories about applications that almost failed, production outages, unexpected bugs, difficult customers, and the engineering lessons that every developer remembers for years. Stay with us.